I guess we should resume. I'm not sure if I record the lecture before the break, but I'll upload the material from the other section. Put the link there, then you will check. You can check that part if you're missing the sample size part. So let's talk about the hypothesis testing. Okay, so there's we'll start off a lot of terminology because of for this set of slides, in 61 slides, it's about hypothesis testing, and there's a lot of terminology there. So we'll start for at least for the first 5 to 6 pages with some new terminology. And I would say hypothesis testing has a lot of material, and they're all very advanced. But we just scratch the surface. So that's why I hope that you would be able to appreciate it via in the new stuff. But anyway, so here we will have two parts. The first part is one sample, the other is two samples. By one sample means we just have a particular group of data we're studying, okay? And two sample actually means two group. Doesn't mean we have two samples, but rather we have two data that also know the grouping. You can imagine, okay? One sample, maybe you can imagine that I look at the data, look at the income of particular area, okay? And two sample, maybe I look at data, I divide it into, say, male or female, boy or girl, young or old, and I will try to see whether the difference between the grouping has some meaning. Okay, so that's a main idea. So, but we focus on one sample, and so far we have been talking about one sample, all the stuff. So just start with one sample would be the most appropriate, and two samples will be needed when we talk about when we later have some categorical component that would be something we would be interested in those. So in general, what is hypothesis testing is we try to see whether a claim have been supported. Okay, a claim supported by a sample. Okay, and do note that there's a subtleties here. Is here we are saying that a claim is supported by this outcome of a sample. Okay, and with the claim we will call the null hypothesis. Okay, and we try to see whether that is true or not. Right? Suppose we say mu is 3. Okay, or the pi, the proportion is 5. Okay, so these are the two things probably you want to check, right? Then, but if this is not true, okay, we will hold the alternative one, okay? But the sample just to test whether the null is true, okay? It's not going to say the alternative is right or not, okay? So that's why the sample is trying to see whether we can reject H null or we fail to reject H null, okay? Okay. This is also the terminology actually used like in the court system, right? In the common law tradition, right? You have the null hypothesis, the defendant is innocent, right? And then you collect sample. Here is evidence, right? Okay. You would say the defendant is always innocent until there reasonable doubt from evidence that prove the other way around that is guilty, right? And then you will be saying that these two are not swappable, right? If you swap, things will be different, right? So what is in the H now will be a little bit different, right? Because probably you know in some other law system, not in Hong Kong, okay, then they would put you assume you're guilty until you're proven otherwise, right? In those cases, then everything will be different, right? So that's how you treat what is innocent, what is guilty, where you put it will be important. Okay, so just to recap, the major logic of hypothesis testing is you have the null is assume it is correct. Okay, this is the what we call the working assumption or working hypothesis, right? The assumption. Okay, and then what you're saying that is try to see if this assumption is supported or not. If not, then you will try to reject it and try to have the alternative as a working assumption. Okay, so let's see the next slide. But before that, just to let you know, there's a two keyword here, null hypothesis and alternative hypothesis, which we will be using throughout the chapter. Okay. So there's two terminology, H null or H0, H1 or HA alternative. Now, let's see the following. So that's the types of hypothesis, okay? And there were two types. One is called simple. One is called composite, okay? And simple actually is more like point estimate, a point, okay? We're saying the probably you a particular value, okay? It's a point, okay? And if within some interval, like mu is bigger than or equal to 3, or mu is bigger than 3, also fine. Don't have to be equal. But these two are the different thing. And for our purpose, okay, for this class, our null hypothesis are always simple. Our alternatives are always composite. Okay. Why the case? Because these two are the most simple case we can analyze. Beyond that will be more complicated. Okay. Is that a question? Okay. If no, then we will go into the give you further now alternative. Here, the slide is slightly reorganized, but the same as your slide. Just add one or two sentences that I think that would be useful. The two types are one-sided and two-sided. Okay. For the alternative, this is a two-sided. Maybe I just erase it. This is two-sided. Okay. Two-sided means not equal. Okay. Means when equal to 3, then the alternative is not equal to 3. Okay. So why we have two-sided? Because we do not know what's alternative. Okay. If I know what's alternative, then it's fine. Okay. In application, what is alternative? Why we use this alternative is the deviation from 3 from both sides. The consequence will be serious. Okay. The example is like, okay, suppose auditor, right? You want to make sure that the company had that number, okay? Say number of inventory, or number of receivable, or number of debt, okay? Those things you have to get exact. You don't want more, you don't want less. Both overestimate, underestimate would be a problematic. Okay, so that would be you would use this. Okay, and in the case you want only one dimension, one direction will be a problematic, right? Suppose if you look at product control, right? Harmful ingredient more than certain amount will be an issue, right? More than that, that would be problematic thing, right? Or if you claim the main ingredient, right, for medicine, right? If the main ingredient is below, not medicine, maybe a food, right? Medicine probably very accurate, right? Maybe very good idea is medicine, right? And you claim some, maybe this is good, is a goal, right? You said 99% of them are the goal, right? That is, if you below the purity, right? Maybe the best thing is the purity, right? The purity of, right? Purity will be, you want it to be less than, right? If less than that amount, then you would be big concern for you, okay? So we know the alternative should be, and in the other word, one-sided would be important, okay? Is that clear how we decide the alternative? It depend on which consequence will be a big issue there, okay? And of course, in most cases, you do two-sided, but there are scenarios that you focus on one side, as we said. And later you will see that not too much difference between the two. It's just how you do the testing, but that will be the case. Okay. If there's no further question, we proceed. Okay. And the next step is what we call the when we make decision in statistics, there are two types of error in general. Okay. And if the null is true, okay, and you can still reject it. Okay, the reason why, because we are doing random sampling, the randomness will also lead to the problem. Okay, so this is, we define this called alpha, and later you will see 1 minus alpha, okay, is called confidence. Okay, see here. And this is the thing that closely related to what we have seen in the interval estimation, okay? And we will call alpha level of significance, okay? So is how much we allow this to happen. So this is the choice, is our choice. Okay. We just allow how much randomness we tolerate. Okay. Because even this is true, we will be rejecting. Okay. And type 2 error is if the H null is not right, okay, you didn't reject, that is called beta. And 1 minus beta is called power. Okay, so there's nothing but terminology. Okay, alpha is type 1 error, beta is type 2 error. 1 minus alpha is called the confidence, alpha is called significance. 1 minus beta is power. Okay, so that is that's terminology. So there's nothing to understand, but just this is just something to remember. Okay, I hope that's all right, but because there's nothing to understand, just to remember. So here is something probably we would need some understanding. Okay, so H null is either, there's four situations, right? H null is either true or false. Okay, when you do decision, okay, it's either you reject H now or not, right? So do note that we don't say except, okay? We never say except because that's terminology we never say except. Either we reject or fail to reject, okay? And if you do not reject the true now, then the probability one is alpha. If you commit a type 1 error, right, it's alpha, okay? If it's false, you reject it, is the power 1 minus beta. And if you commit the mistake, it's beta, okay? And later you will see we can free to choose our alpha, okay? And there are trade-off between alpha and beta, okay? And for given n, okay, if we know the alpha, we fix the beta, okay? And if you want to lower the beta, you need to increase n, okay? So basically is sometimes we don't want too small alpha because when we're small alpha, the beta will be a problem. The beta will be higher, okay? So that's why there's trade-off there. It's not the smaller the better, but we still have some reason not to go the lower, right? So that's why alpha or 1 minus alpha, right, is sometimes 90%, 95%, or 99%, right? This is the three common thing. You don't see 99.9999999 because if you do this, the beta will be much higher. So that would be, from rule of thumb, turn out to be 95, 90, 99 would be a somewhat mostly often used, and the most commonly people would use is 95. 95 is something people would take it, and 195, I don't know, but historically this is the rule of thumb. Okay. Now there's a lot of terminology as I've said, so let's go into the procedure. Okay. So this is the procedure that we use throughout the chapter, okay? Even when you talk about two sample, okay? First, you need to state the null and alternative hypothesis, okay? As we have said, our case null is always mu equal to a certain thing, okay? And the alternative is mu is not equal to, or mu is bigger than, or mu is smaller than, okay? So that would be coming from which one to be used depend on situation. As we said, depends on the consequence. Okay, if both sides violation, then you'd be using this, right? If only one side of violation is important, depend on which side, then you would use one of those. Okay, and once you state it, you collect the sample, right? So based on the sampling outcome, you would compute the test statistics. Okay, what is this? It's unclear what it is, but later you will see. Say you want to estimate this is by sample mean, right? So based on the sample mean, you want to calculate what the test statistic is. Okay, so the idea is, I can talk about it here now. Say the idea is the following. So the main idea is mu, okay, is something we want to know. And by central limit theorem, mu has a normal distribution, right? Okay, and I claim mu equal to A, say, okay, it's A here, okay, and depends on this. This is an alternative, but now suppose the alternative is mu is bigger than A. Okay, so suppose this is the case. This is H0, this is H1. Okay, and what it means is mu is sufficiently large, then we will say this is a problematic assumption, right? So that means if we collect a sample, okay? Which I should say the distribution should be the X bar, sorry. The distribution of X bar. Okay, so, and if you, this is the distribution, suppose you get, when you do actual data, you get this number, okay? This is the actual sample we got, okay? This from the sampling outcome, okay? The question is it far away from A to say H now is not support, okay? How can we decide this, okay? And then this we will convert to some number, okay? And so that we will try to see if, okay, it is far away enough, which means that if this is the possibility of having this, how big is this, okay? If this is far, far, far away and this is super small, and we will say this cannot be true, okay? And how this looks like, right, depends on whether we know sigma square, okay? If we know sigma square, right, this, we have a normal distribution with mean mu sigma square over n, right? The test statistics in this case will be z is equal to x bar over mu over sigma over root n, because this is normal. But if you don't know sigma, we should t-test. The t-statistics will be mu over s over root n, okay? Because this follows the t-distribution, okay? And this is what we call the z test statistics. This is called t-test statistics. And then we try to see if this is too small, and then we reject, okay? And the two ways to see it, either we see critical values and we see p-value, which will become clear later. And we will do decision based on comparing this, okay? But let me go to the example, then you will see more clearly what we are actually doing, okay? Still now probably a bit not easy to understand, but the key here is we are talking about sample mean, and there are two ways to do it, because as we just write, if we know the sample variant, so population variance, this is normal CO1, okay? But if you don't have any idea, okay, that will be dispute with Tn minus 1, okay? So that will be just t-test. This is called z-test, okay? Z-test will be just test based on standard normal. T-test will be used based on student T, okay? That's only the two things. But let's give you the example, then you will see it's not that difficult, okay? So let's start with the following, okay? As we said, we always have a null is sample mean is equal to some number, okay? For our introductory exercise, okay? And the alternative, we focus on the cases bigger than, and then we'll talk about less than. That's the same idea, okay? You see that this case is a mirror case, so symmetric. Now, the first thing we know is we get the data, we get a sample mean, okay? Sample variance is not useful because we know the population variance, okay? From central limit theorem, we know this thing would be true, okay? This is coming from central limit theorem, okay? That case is when n is bigger than at least some 30 something, okay? Then this would be a good way to do it, okay? And, okay, now we need to decide why this would be useful, right? So how to make decision based on the null, okay? Remember how we make decision. We make decision is based on assuming this is right, okay? And if this is violate, it is not easy to see this is true, then we will reject it, right? The same as in court, right? Assume innocent, if beyond reasonable doubt, that would be reject. Okay, so what's the idea here? So assume this is true, okay? The sample mean, right? We'll have the distribution like this, right? Assuming. Okay, do note that this, we assume the sample mean is true, right? So this is replace A here if this is true, okay? So there will be A here, okay? And it will follow this distribution, right? And the variance will be, of this will be sigma square over n, okay? Now, what we get from the data, okay? Suppose is, if this is the data, okay? If suppose this data, okay? Then we don't even need to do hypothesis testing, right? Because we're saying, oh, if only the evidence more than that, we reject, right? If less than that, actually, we don't even need to do, we don't even need to go further. Okay, that's fine. We don't find rejection, right? And now if it is bigger than this, the data tells us this here, then do we do rejection? Do we say this data is violating this? Okay, not so fast. We need to see, okay, how likely this is happening, okay? How likely this and even more extreme is happening, okay? Is it far away from A? If far away from A, then yeah, that probably is not so good, right? How to determine far away from A, right? It's asking this probability, is it small enough, okay? If this probability is small enough, then we say this far away, right? When it's far away, then we will say, okay, reject, right? It's unlikely this happening, right? Because if this, or even worse, is very unlikely, then it's not going to say it, right? Assume this is true, right? Just asking the probability that the X bar, right, is bigger than, I don't know, this number called B, okay? It's bigger than B, okay? Is very, very small, okay? In particular, is less than alpha, okay? Which is the level of significance or level of type 1 error we tolerate, okay? Then we will reject, right? Because the procedure says long enough we will reject, right? And this is exactly type 1 error because assume this is true, it is also likely that this will happen, okay? Alpha percent will happen. So we will set, we are going to set the alpha is the significance level, but this alpha is also the type 1 error. Is that okay, what we're doing here? Okay, just to repeat, alpha is the level we set in advance. What do you mean by the probability is small? Okay, and in this particular case, happen to be same as actually with the type 1 error. Okay, and okay, so that is the case. So how do we proceed from here? Okay, is we try to check. Okay, we try to check if. Okay.
冇嘅，刷得快即係用得快。
Sorry. I don't know what to say, but I'm not sure. So what is here is what we're doing again. Let's repeat because that's so important. So this is X bar, okay, and according to the null hypothesis, okay, this mean should be A, okay, and alpha, okay, the alternative is mu bigger than A, right? And how do we decide whether we want to reject mu equal to A and instead we accept mu Okay, this is H now, this is H1, right? When do we say this is not true? Okay, if this is so further away from A, okay? It's very further away from A, okay? How do we define further away from A, right? We define in terms of probability, right? Because depend on the shape. And then we say, if this is alpha away from that, okay? Alpha is between 0 to 1, right? That we call significance level. Okay? Or confidence, level of confidence, okay? So is that okay? There's some question. So if this is small enough, then you reject, okay? So how do we do about that? Okay, that means that if the data, okay, fall within here, then you reject, or here you reject, right? And how do we calculate this? Is we usually transform this to the Z space, okay? Because that is how you have the thing, right? Instead of A, you have 0 here. So this is how we transfer into this one. And this is alpha, right? And that means that this is Z alpha, okay? And you compare this green thing to the alpha, C alpha, okay? If the green thing is bigger than Z alpha, you reject. If C is less than Z alpha, you fail to reject, okay? Or the other way around is look at the green, look at the area above the green, the data you have, which is called p-value, okay? And if the data is above, the p-value is less than alpha, you also reject, okay? The green area is bigger than the alpha, then you don't reject, okay? So that is the idea, okay? Probably that is a little bit tricky, but let's see the example, then we will, you'll become more clear, okay? So consider the following, okay? Given that the standard deviation is 4, okay? And the random sample size 64, sample mean is 5, okay? And the null is given to you. How you come about this is coming from the problem. Other problem is given. So this is the problem given is given by 4, okay? And as we said, this is also given by the problem more than 4 will be problematic, okay? So that's why we have more than 4, okay? Now, first, if the case mu, let's say x bar is 3, if that's the case, we don't even proceed further. It is done. If it is like this, the sample gives you this, then we don't need to do anything because it's not violating this. It's not inconsistent with this, then we don't even consider, okay? Now we have the case where x bar is 5. It's more than 4, okay? Is it more than 4? Okay, significantly more than 4, okay? If it's not, then we are not going to, we are going to see if the more than 4 enough, okay? So let's see what this is, right? Assume this is true, okay? So assume this is true. Okay, so this is the distribution we have, x bar, okay, with mean 4, okay? And this sigma square over n, okay, will be 16 over 46, okay? This is the variance, okay? Or if you want the SD, okay, will be 4 over 8 is 1/2. So it will be sigma over root n. Okay. And now we're looking at 5 is here. Okay. The question is again, we want to know if this area, okay, this is called p-value. Okay. Okay. Is it bigger than alpha or smaller than alpha? Okay. If smaller than alpha, then it's so far away from 4, that's we reject. Okay. So how do we proceed? Check whether 5 is bigger than alpha or smaller than alpha, right? So you can, now the Excel, you can do it directly, but in the old day, you need to check the Z table, right? So that's why you would convert in the Z table. Okay. This is 0 here. What's 5 here? You convert this based on this conversion. This is 2. Okay. And you want to see what is the p-value here. What is the value here? Okay. And what's the value here? You can use the formula, right? From Excel, 1 minus norm S inward 2, okay, will give us this answer. Okay, because this is probability Z less than 2, okay, 1 minus that is equal to this. Okay, so you can see this is, the area is much less than 0.5, okay? So this area is less than 0.5, so you would say you would reject because it's so far away using 95, using the 5% significance level. Okay. Or in the old days, actually, you don't have this Excel. So actually, that's why classical textbook would tell you, okay, you don't use this method. Instead, you are telling us, okay, what should be the 5%, right? So usually the textbook will ask, okay, the standard method is asking, okay, let's calculate 5% here. What is 5%? Or what's alpha here? Okay. The 5% is 1.64. Okay. Where it come from? This is coming from norm as this 0.95. Okay, because 5% on the right is 95% on the left. Okay, 5% on the right. Okay, it's 95 on the left. Okay. Then if this number less than this number, right? Less than 2. Okay. So we reject at 5% certificate level. Is that okay? This procedure will repeat and repeat, so you will be able to understand. But that's the main idea of hypothesis testing. Is that okay? So don't worry, we are going to repeat once more for the other case, so that you will be able to see how it works again. Okay, so you will see the same question, but this is asymmetric. Okay, the other case before with mu bigger than A. So in that case, let me repeat what we are doing here is assume this is true. This X bar, we have a distribution have mean A. Okay, and we are trying to see if our data is more favorable to H1 than H0. Okay, so in that case, we are saying if the data is far away, far below A. Okay, far below A. Okay, and how do we define how far below A is? We want this area. Okay, if this area is less than a number we call alpha. Okay, and then we will say this is small. Okay, and in the other word, right, we are basically convert this to the C space, right? This is 0, okay? And we are asking, okay, compare this to here, maybe I use blue color. Okay. If, okay, this will be, this number will be negative Z alpha. Okay. And then what we are going to see is we are going to collect some data, right? From the data, maybe here, if here, right? And will be converted to somewhere here, the Z value, okay? This value bigger than that, then we are not rejecting, okay? But if the data is here, okay, and we are getting this number, then we'll reject. Alpha is something we design, okay? Very often we set 5.05, or if you like it's 0.1, or you like is 0.01, and these three are the most common, and the date is given by either choice, and you decide what to set, but this the most common is 5%. Is it okay? Because we decide how far away is considered away. This, as we said, this is the type 1 error we allow. And you sometimes don't want to set as low, because if you set too low, the beta will be high. Is that okay? So let's see the question again quickly. So you were able to see that the same thing, right? So the sigma is 4 here, n is 64, and x is also 3. So it's exactly the same, but before we have 4, before we have 5, okay? But now other way around is 3. Okay? And sigma over root n is again 1/2. Okay. So again, the question is h now is 4, h mu is less than 4. Okay. So we're asking if this guy less than 3 is less than or equal less than alpha or not. Okay, less than 5% or not. Okay. If less than 5%, then we say this so far away, then we would rather reject it. Okay. If this is not that enough, then it's not. Okay. So that is the idea. Okay. So the first thing you can do is to, one way to do it is to, very quickly, is to change from the X bar to the Z space, okay? Then this 4 becomes 0, and 3, when you convert, that's become -2, okay? Because 3 minus 1 over 1/2 is 2. So again, you know, if we want 5% here, this number is -1.64. Okay, that means that less than -2, okay, is way less than 5%, right? Because there's some area here. So that's why we will reject, because this is less than alpha. We said, okay, we said this is we decide, okay, and reject it. And alternatively, you calculate what is this, right? This is again coming from norm as this -2, right? And then true, okay? And then give you this answer, okay? I guess that's much for today. Don't worry, we'll repeat. You will see from this slide, we are repeating ourselves many, many times over the T, over the two sides, over many, many, the same style again and again. So you will be getting it. Alpha is the level certificate. You decide this. Alpha is the choice. It's your choice. Usually the question give you, or you decide what is the appropriate level of the type 1 error. Usually 5%. Someone asked me whether we need to do this. This is either you do one way or the other, okay? So you can, so someone asked me whether I need this second part. This is optional, okay? Either you do this part or you do this part. So either you do A or you do B. Is that clear? You don't have to do both. But the reason why you talk about A, because this is the classical way, but now the computer doing B will be much faster. It depends. It depends on what is better for you. Okay, just to, if no more questions, then we should end the section. Have a nice weekend. And do remember that we're quiz next week and assignment due next Friday. So see you. Thank you. Have a nice weekend. I will stay around to answer the question you might have.